Alright, in this video I'm going to go through this problem here. So it's a great problem because if you look at the last few problems that we did these max-min application problems, but we were given the equation. Here we've got to come up with the equation. And so I would encourage you to try this. I'll just give you a little tip. Notice we have two variables here, base and height. So we want everything in terms of one variable. So let x equal the base, and then write the height in terms of x. And then you should be able to write the area of this triangle in terms of x. So give that a try, and then I would encourage you to watch the video. See if you can solve it on your own first. But let's go ahead and go through it. So first of all, with triangles, we'll just draw a typical triangle here. This is the height, and it's perpendicular. This piece here is perpendicular to the base, which we call B here. And here we're told that the sum of the base and the height is 20 centimeters. So the base plus the height is equal to 20. Well, as I hinted, we're going to let x equal b. And so in that case, we have x plus h equals 20. And if you solve for, excuse me, for h, you'll get h equals 20 minus x. Now you've got to know the area. I'm sorry, my throat's dry here. Let's see if I can finish this out. The area of a triangle is 1/2 the base times the height. So in this problem, we said the base is x, and the height is 20 minus x. And I'm going to go ahead and use function notation here. So A stands for area. A of x is still area, but it just emphasizes the fact that the area is dependent on what x is. Alright, so let's go ahead and multiply this out. So finally we get the area. Let's see, 20 times 1/2, that's going to be 10x minus 1/2 x squared. If you want, you could write the area as negative 1/2 x squared plus 10x. Notice this is a parabola that opens down. And so you can see that we will have a maximum at the vertex of this parabola. And so we need to find the vertex. So we have the vertex formula, x equals negative b over 2a. So in this case, it would be negative 10 over 2 times a, which is negative 1/2. So that's going to be negative 10 over negative 1. And so we get 10. Now, that is x, which was the base. We're supposed to find the dimensions for which the area is a maximum. So we didn't actually have to find the maximum area. We just have to find the dimensions for which the area is a maximum. So we know that the height, or I'm sorry, the base, we said x is b. So the base is 10. We're dealing with centimeters here. What about the height? Well, we said that height was 20 minus x, so that would be 20 minus 10, which is 10, and so the height would also be 10 centimeters. So these are the dimensions. Whoops, you can't even see that. These are the dimensions. Let me make this just a little smaller. Those are the dimensions that give you the maximum area. So if you wanted to actually find the maximum area, if you'd been asked to do that, you would just plug in 10 here and here, and you could find that maximum area. The other option would be to actually plug 10 into the function. That's what we normally do. All right, so that's it for that problem there.